So yes. In the previous class, we discussed about the flip-flops, how we use this flip-flop like RS flip-flop, AK flip-flop, T flip-flop. We will cover in the previous class. If you have any doubt, you can ask me the questions. No doubts? Yes, students. If you have any doubt, you can ask me the questions. Okay, so in the V10 content part, we discussed the SR latch, clock SR latch, JK flip-flops. Now we go with the T flip-flop. What is the meaning of T flip-flop is that? This is one flip-flop, where T is the input, clock is applied, we are getting Q n plus 1, Q1 plus 1. Okay. So if we say that T is equal to 0, okay, consider the always clock is applied. Okay, so when T is equal to 0, my next state output will be equal to the present state. Okay, and when T is equal to 1, my next state output will be the toggle of the present state. So that's why it is called the toggle flip-flop. Okay, it is called the toggle flip-flop. So if we draw this is the truth table. If we draw the characteristics table, so the input is T and Q, and output is Q n plus 1. So T is 0, where the Qn is either 0 or 1. So what we are getting? We are getting a 0, we are getting a 1, as it is. Okay, and when T is 1, Qn is 0, 1. So when Qn is 0, Qn plus 1 is 1. When Qn is 1, Qn plus 1 is 0. Okay. So now if we draw that particularly, so Qn plus 1 is nothing but T XOR the T XOR. So this is the toggle flip. So this is the toggle flip. Okay. Similarly, if we know that when J and K both are 1 1. So what is the Qn plus 1? That is the toggle condition. Okay. When where J and K both are 0 0, so what is the Qn plus 1? That is the Q1. So if we use a JK flip flop and use as a T flip flop, we are getting what? This is J and K flip flop. Okay. We are getting a Qn plus 1 and Q. So when we short both J and K, okay, when we short both J and K, so when we apply the 0, Qn plus 1 is Qn. Why? Because it is a JK flip flop. Okay, JK. Now, when we apply the 1, it is JK is 1 1, and we are getting a Q1 plus 1 is equal to Q1 plus 1 bar. So, from the JK flip flop, I also designed the T flip flop. Okay, any doubt?
So here we are taking J and K as equal only.
As a equal on. Okay, then it will be behave as a T flip flop. Okay,
So its equation will be what, sir?
if we are talking about uh, the question about what?
So its characteristic equation by
Characteristic equation.
um,
For this scenario,
yes, sir. Means
no, that is that
we are
is that
using
is
T flip
different. That
flop,
is
no?
different. We are using JK flip flop, okay, as T flip flop. So how we use that JK flip flop as a T flip flop? This is the way. Okay. So what we do, we short this particularly because we know that JK flip flop table. In the JK flip flop table, we know that when JK both are 0 0, we are getting a QN. When JK is 1 1, we are getting a QN bar. Okay.
And so if we do
Similarly,
vice versa,
yeah, T is equal to
we
1, we are getting a Qn plus 1 bar, and when T is equal to 0, we are getting a Qn. So what should we do? If T is 1, that means JK both are 1. So what we do? We just short this. When T is 0, that means J and K both are 0. So we short this two terms. Okay? Yes. Any doubt? Yes, what is your doubt actually?
sir, if I have to make a JK flip flop by T flip flop, so
JK flip flop by T flip flop, we are using the excitation table for that. Okay, we have to drive the excitation table. So let's I just draw the excitation table. Okay, here we are having 2 plus 1, what is the T? So when both are 0, 0, T is 0, when both are 0, 1, T is 1, when both are sorry, 0, 1, 0, 1, 0, 1, yeah, T is 1, 0, 0, T is 0, 0, 1, T is 1, 1, 0, T is 1, and 1, 1 is okay. Clear? Now with the help of JK flip-flop, we already know the JK flip-flop truth table, excitation table. So what is the excitation table of JK? JK is 0, 1, cross, cross, then cross, cross, cross. Okay. Now can I write down the J equation of J using the T and Qn? Okay. Similarly, can I write down the equation for K using T and Qn? Yeah. So if I write down a JK equation, so JK is one input is T, one input is Q. Okay. So JK is one is where when T is one and Qn is zero. So T is 0, 1, when T is 1 and Qn is 0. T is 1 and Qn is 0. Yeah. Okay. And in these two conditions, JK are don't care condition. When T is 1, Qn is don't care. When T is 0 and Qn is 1 is 0. So I create a group here. Okay. So the equation of J is T. The equation of J is T. Now what is the K? So we go K naught for K, T Q 0, 1, 0, 1. Now where is the K is? So K is down here. T is 1, Q is 0, T is 1, Q is 0, don't care. Now T is 1, Q is 1. Here, it is a down here. So now we created group here. Okay, so K is also. This is a statistic. Remember the excitation table we discussed in the previous class? What is the excitation table of JK? It is correct or not? If this is the excitation table, like for example, if I assume that this is the excitation table, so according to this one, and this is the JK, this is the oh, this we convert to the we are using this one as a J and K both are T. So if we are using J and K to flow 2n plus 1, 2n plus 1 bar, we connect both with the T. So this is the excitation table. This is the result. Now, if we use T flip flop as a JK flip flop, if we use T flip flop as a JK flip flop, then this is the T 2n plus 1, 2n plus 1 bar. So what we do, we are creating a J A Q1 0 0 0 0 0 1 0 1 0 0 1 1 1 0 0 1 0 1 1 1 0 1 1 1. What is the Q1 plus 1 0 1 0 0 1 1 1 0? Okay. Now with the help of this one, I create a excitation table for JK. 1 plus 1, this is 0 0 0 1 1 0 1. What is the J? K 0 1 cross cross. That is cross cross 1 0. Okay, and what is the T? T excitation table is 0 1 1 0. Okay, now we create a K map for T. Create a K map for T using J and Q. Now T is 1 when J is 1 and Qn is 0. J is 1 and Qn is 0. And T is 1 when Qn is 1. Qn is 1 for this one. Either J is this one or this one. So both solutions. Okay. Now create a group. So one group is this one group is this one. So what is the P equation is for JK? JK is J plus Qn. Okay. Similarly, we draw a K map for K also. Using K also. T K Qn 0 1 0 1. Okay. Now when T is 1, when K is cross and Qn is 0. So Qn is 0 for this. So 1 1. And last one when K is 1 and Qn is 1. That's it. Now create a group. So this is one group, this is another group. The question is K plus Qn bar. Okay, K plus Qn bar. So how we design? This is my T flip flop. Okay, this is my T flip flop. J with the Qn and K with the Qn bar. Sorry, using the OR gate. J plus Qn. So J plus Qn K plus Qn bar. Ending these two can be applied as a T. Okay, so that is a T flip flop using JK. Sorry, JK flip flop using T. JK flip flop using. Okay, so in this way we design. That's what I was saying. So for here we use not gate to gate. What is the meaning of this for QN bar? We use not gate. Yes, Rohit, what you are saying? Rohit, we are already getting the QN bar now. So why we are using the not gate? Okay. Any doubt? So now the next is the registers. Okay. So what is register? Register is nothing but a combination of flip-flop, combination of flip-flop to store more than one bit. Okay, to store more than one. Okay. For any storing element, for any storing element, we require registers. Okay. Now we store one element, one bit with the D flip-flop. Now if we store a multiple bits, so we are using a combination of D flip-flop. Either the combination in this way, clock pulse, okay, clock pulse, where we are using one as an input, P0, P3, P0 we are using a P1, P2, P3, Q3. Okay, or we can use in this way as a P, so P0, P1, P2, P3. This is the clock pulse, equals we are getting an output 20, Q1, Q2, Q3. Okay. So can you see any difference between these two diagrams? Can you see any difference between these two diagrams? Yes, any doubt? Any difference between these two diagrams? Okay. No idea?
So
Yes
the
or no?
downward is parallel loading resistor and the upward is the shift resistor. No?
Yeah. So upward we say that it is basically the shift resistor or serial resistor. Serial resistor. What is the meaning of serial resistor is that every bit is inserted one by one. Initially you bit at D0. Okay. Now in the second clock bus, this D0 bit will be go to the next register and you insert one more bit. Okay. Now after that this particular bit will be go there. The previous one will be go in this one and you insert one more bit. Okay. And after your next clock bus, this bit will be go this way. Okay, so with every clock bus, the data will be shifted one by one. So in this way, you are getting your data. Okay, so this is a serial register. Now here, this particular combination, this particular diagram is called the parallel. It is called the parallel register. So what is the meaning of this parallel register? Is that when you apply the 4 bit as the input, okay, and similarly you apply the clock bus, so these 4 bit will be going inside. Okay, these 4 bit will be going inside the flip. Okay, and you are getting that. So 4 bit parallelly transfer the flip flop and it will be ready. Okay, so that's where it is called the parallel registers. Now registers are classified into categories. One is the synchronous, not register synchronous. Okay. So there are two types of registers are available. One is the serial register, second is the parallel registers. Now on the basis of this one, we classify our registers combination in a group of four. In a group of four. So what it is say? Either the data will be serially in and serial out. Okay. That is called the CC. Second is serial in, parallel out. It is called the C4. Okay. Third is parallel in, serial out. PC. parallel, parallel. Serial and parallel persistent people. Now, with respect to CISO and PIPO, we are getting the CIPO and PISO also. Okay. So, four combination is possible: serial in parallel out, serial in serial out, parallel in serial out, and parallel in parallel out. Now, with respect to this particular flip-flop, we are taking that if any data will be going in, it will be taking one clock cycle. Okay, and if any data that is out will be taking a zero clock cycle. Okay, if any data will be going in, it is a one clock cycle. If any data will be out, it is a zero clock cycle for a single. Okay, like for example, if this is your D flip flop and you apply zero, so this zero is at this point. Okay, it will be not going inside. Why? Because you are not applying the clock pulse. When you apply the clock pulse, this zero going to the inside of the flip flop. Okay, so one clock cycle is required for this input will be going inside the flip flop. Now, when it will be going inside the flip flop, you are getting the instantly output. Okay, if D is zero, you are getting as a zero. If D is one, you are getting it. So in this way, we can say when any data will be going inside the flip flop, it will be taking a one clock cycle, and if data will be going outside, it will be taking as a zero clock cycle. Okay. Yes. No.
Sir, how sir for data means there will be no zero cycles, means no clock cycles.
Why no clock cycle? Because when the data is going inside the flip flop, it will be taken. It will be going outside at an instant. Okay. So if we divide this particular part in this particular, like this is a line. Okay, this is a line, inside line. Okay. So from this input point to this point, it will be taking a zero clock cycle, one clock cycle. Okay, and with respect to this one, we are getting a zero clock cycle. If we are talking about this to this, it will be taking the one clock cycle. If we apply D, if this is my clock cycle, okay. Now if my D is zero, like this one, okay, and what is the Qn plus one? At this instant, it will be checked the data is zero. So when you apply a clock power cycle according to the data, it will be the zero. Okay. Now when you check at this clock cycle, when the data is one, when the data is one, it will be behave as a zero. Why? Because clock cycle is not applied. If clock cycle is not applied, you change the d value either zero or one, no issue with that. Okay, no issue with that. When clock cycle is applied, when clock positive edge is applied, your data will be going inside. Okay, and according to this one, you are getting a data out. Clear? Now it will be maintained as a constant. Again, at this clock cycle, it will be again checked. When the data is 1, it will behave as a 1 clock. And so 0, 1, and 1 is the data output. Okay. So in the case of flip flop, the output will be changed at every positive edge. Every positive edge. Okay. Any doubt? Yes or no? Yes or no? Hello. If you remember the diagram, we have designed the AND gate and using the NAND gate and NOR gate, we design a diagram of D and JK SR. You remember that one? Like for example, SR flip flop. If you remember that we design a one NAND gate. Okay, one NAND gate here. This is the R. This one is the S, and we are using a clock. Okay, so either you change the S and R, no issue. But till now, your clock is not applied. You can't say that your data will be going inside. Okay. After that, you take a second step. You remember this diagram? So, clock signal is required for the entering of the input signal. Entering the input signal. And when the input signal is entered, there is no particularly clock is required to getting the output. Why? Because inside the flip flop, only the thing is that there are combination of the logic gates. So for the logic gates, no clock pulse is required. Okay, if you see the second stage, so no clock pulse is required. So before entering the data inside the flip flop, we require a clock. Okay, so for entering, we require a one clock pulse signal, and when the data will be entered, we are getting without any clock pulse, we are getting the output. Is it clear? Now, yes, any doubt? Any doubt? So now if we have a clock pulse, clock pulse, what is data? my data is one, I'm taking one. Okay. The data is a 7 bit data. So we are 7. Now you so in this case we are not considering any queue till clock is okay, till clock is applied. Now when clock is applied, if data is 1, so we are getting data is 0, it will be remaining constant. So we are not considering this. Okay, after that second clock pulse is applied, we are checking that what is the data. So if data is 1, we are getting 0. Okay, so only which data will be eliminated? First one data. Why? Because it is applied before applying the clock. So only we are getting it to 1. We are not getting a first packet. Now the Q is also a 7 0. Okay. Now if we are parallelly added, like in this term, like in this term. So if clock is 1, we are getting as a Q 7.0 equal to input 7, and else Q 7.0 is equal to or not. We are saying that it is equal to 7. Okay. Here we are using the Q n plus 1, n plus 1 into, okay, for any term. So if clock pulse is applied, we are getting a next output is similar to the input. But if clock is 0, we are getting a same output that we are getting in the previous. Okay. Now that definition is completely changed when we are going to the serial. Why is it related? Because when we applied a clock signal 0, when it was a single clock pulse, when we apply a single clock pulse, what is the meaning of this one is that the data D0, or we can say the when we apply a clock signal pulse, we can say that Q0 is equal to D. Okay, When we apply a second clock pulse, when we can say that Q1 is the, when we apply a third clock pulse, we can say that Q2 is the, and when we apply a fourth clock pulse, we can say that Q3 is the. Similarly, time this Q0 is the beta 1. Okay, same this way, we have Q3, Q2, Q1, Q0, T0 is 0, so initially 0. Now when T0 is 1, so 1 is inside here, is 0. When we apply the T1 is 0, so 0 is inserted here, 1 is shifted here, and when we apply the T0 is 1, so 1 is here, with 0 is shifted here, 0 is shifted here, okay, so after applying the fourth data, after applying the four data to clock bus, we are getting a first output as a two. First output as a two. Okay. Yes. Any doubt? Any doubt? Shall we move further? Now, if we are taking one control signal, that is a load. Okay, if we are taking the control signal, that is load. So we are using a 1D flip flop here, and that is clock. Okay. 2n plus 1 and 2n. Now, what we do when my load signal is 1, we are getting a okay, but this particularly we are getting a we are getting a output. So we know that in the D flip flop there are two input is possible. One is the this original input and one is the clock signal. Now this original input, if we connect this original input with a circuit combination of circuit in a way that here I connected D and load signal, and we are getting a we are okay. Now which combination circuit we are using? We can implement with the AND gate. We can implement with the AND gate. Now it is a D, it is a no. If load is 0, D is either 0 or 1. In every cases, we are getting an output as a 0. Okay. So this particular condition is
Okay, so when load is on, the signal is transmitted. When load is off, signal is not. So we can use one combination circuit as an AND gate. Second, we can use as a MUX also. Okay. Here we connect as a zero and here we connect as a load. If load is zero, we are getting zero. If load is one, we are getting it B. We are getting it. So we can use any combination circuit that is
Basically controlled by the loads.
that is controlled by the. Yes. Any doubt? Any doubt? No doubt? Okay. So I think we stop there. If you have any doubt, you can ask.
Hello, sir.
Yeah.
Actually, sir, I wanted to ask that is there any extra questions or PYQs to solve the what you can say for the next for the end term exam? So, is there any PYQs or extra questions for that?
Any extra questions? Extra question
Yeah,
related to which weeks you are required?
sir, from week 1 to week 10, week 11, any means,
Okay, okay, okay.
any means
So,
PYQs.
so we can
And
do
sir,
one.
where you sir upload that extra questions or anything? Because I don't have idea that
Either it
where the extra.
is I upload that particular extra question on the G space or basically a Discord form. There are the only two ways. Yes, so I will just upload some extra question on the G space tomorrow. Okay, not for week 1 to week 10. I just upload I think week 1, 2, 3, 4 only. Right now,
Okay,
after
sir.
that 5, 6, 7, 8, I will upload that. After that. Okay.
Yes, sir.
So thank
Hello.
you all. Yes.
Yeah, as we were heading to the end term exam there right now, so there will be exam in within next 3 weeks. Okay, so what will the approach we should follow with the end term exam? So GAPA are the basically videos and all that is as per the quiz one and quiz two, but
Yeah, exactly. The similar to the quiz one and quiz to the end term exam is done.
mhm.
Okay, so the question will be related to somehow similar to the GNPH. Okay,
Okay,
not same question. Some
yeah,
values
yeah,
will be
yeah,
changes. The pattern
that
will
is
be similar.
right, right.
The
That
pattern
is
will be similar.
understood. And the tentative syllabus 1 to 12 week or that
1 to 12 week. 1 to 12 week.
okay,
The more maximum part will be covered from the week 9 to 12.
okay. Tentative percentage wise 80%.
Mm, Exactly, I have not calculated. I will
Okay.
tell you this one on the Wednesday.
Okay, it will be better to because we need to
I
plan it
will do one
properly.
thing. I will do one thing is that on the G space, basically in the Wednesday class, I will tell you that week 1 to 4 is this percentage, week 5 to 8 is this
Right,
percentage,
right. It will be
and week
better.
2 to 12 is
Yeah,
this.
because there's then 3 weeks to go for the end time exam there,
Hmm.
and a lot of things we need to go through and prepare and
But I think, as I remember, that maximum part will be from week 9 to
9 to 12.
12. But how much percentage, I am not sure of that one.
Yeah, it will be better if you disclose it thing there now,
Yeah,
because
I will discuss.
already we have gone through the weeks all that
Hmm.
we have prepared it for quiz and quiz to there. But
Hmm.
again, that we need to revisit and just recall all these things and
Hmm.
prepare
So
the
I will
better.
disclose